Hi friends, it's Barry from Math Games, and today I want to show you how to do this algebra puzzle from the University of Cambridge. So pause the video and give this a go, and when you're ready, keep watching for the solution. So let's take a look. We have an equals minus 1 raised to the power of n minus 1, and then raised to the power of n minus 1 plus minus 1 raised to the power of n plus 2 for all n integers that is greater than or equal to 1. And the problem wants us to find the sum of all an's from n equals 1 to n equals 39. And the symbol we have here is known as the sigma, which is the summation notation. So here's what we will do. We will write out the an's, but we want to test out what an's would look like given some of the values of n. So let's try what happens when n equals 0. So when n equals 0, we have a0. Okay, so no, not 0, but when n equals 1, we have a1. So that is minus 1, and then 1 minus 1, and minus 1, so 1 minus 1, and then plus minus 1, 1 plus 2. Okay, so here we have minus 1, and then here is just minus 1 raised to the power of 0. So again, this is minus 1, and then this is minus 1 raised to the power of third, an odd power, so we have minus 1 again. So this is minus 3. So let's highlight that. Okay, let's find a2. So a2, we have minus 1 squared, and minus 1, minus 1, 2 minus 1, and then plus minus 1, 2 plus 2. So minus 1 squared is 1, and then minus 2 minus 1, that's 1. 1 raised to the power of, minus 1 raised to the power of 1 is just minus 1. So, and then here we have minus 1 raised to the fourth, so it's 1. That is 1 plus 1 plus 1, that is 3. Okay, let's highlight that. Now, let's do a3. a3 is minus 1 cubed minus 1, 3 minus 1 plus minus 1, 3 plus 2. So here we have minus 1 because it's an odd power. And then here we have minus. In here is the power is 2, so that is 1. And then for the last part, we have minus 1 again. So that is minus 3 once again. Seems like there's a pattern, but we have to check for a4. So a4, we have minus 1 raised to the fourth power, and then minus 1, 4 minus 1, plus minus 1, 4 plus 2. So minus 1 raised to the fourth power is just 1, and then we have minus 1 raised to the cubed, so minus 1, and then here again an even power, so we have plus 1. So adding them all up, we get the number 3, a positive 3. So it seems like the pattern, ANs, there's a pattern. It seems like it goes from plus 3, and then, no, it goes from minus 3, and then plus 3, minus 3, plus 3, so on and so forth. And I will tell you that this is in fact the pattern. Of course, you can try and prove it, but that's not the point of the video. So we know this is the pattern, right? Where for n equals an odd integer, we get minus 3, and then for the even ones, we get plus 3. So we want to find from n equals 1 to 39 of an. So what do we get? Well, we have a1 plus a2, and then plus a3 plus a4 plus. And then all the way, we have all of these pairs all the way to A37 plus A38. And then we add one more, A39. So let's take a look at some of these pairs, right? So we know A1 is what? Well, A1 is -3, and then A2 is a +3, as we have from here. So this pair is 0, and the same reasoning goes for each of these pairs. So all of these are just -3 and +3, so they're all zeros, right? All of these are all zeros and zeros. So essentially, we can ignore all of these terms, or the first 38 terms, and we just have to think about what the 39th term is. Well, 39 is an odd number. So from here, the odd term, we know that will give us a -3. So the answer of the summation, right, is simply -3. And that's our answer. How amazing. If you enjoyed this video, please like, subscribe, and comment your approach. And I will see you in the next one. Bye bye.